Okay, we have MP7, look for and make use of structure. I'm Resa.
And I'm Megan.
We'll just clarify things a bit more. So our first sample problem is, Jill had 72 candies. After giving the same number of candies to each of her 3 brothers, she had 48 candies left. How many candies did she give to each brother? So we have our sample student here, Megan, and she's going to attempt the problem first. Here you go.
Thanks. No pressure.
I know, I feel like I'm gonna mess something up. 3 brothers? 8
Okay,
candies.
so as you can see, Megan came up with an answer, 8, so let's see if she did that right. All right, and the correct answer is 8. So let's just go about how we would solve this problem together as a class. So that we know that Jill started off with 72 candies total. So we made this little number line here that shows 72 candies. And then she gave the same number of candies to each of her 3 brothers. So we just drew a little segment of 3 question marks because we don't know how many she gave yet. But we also know that she had 48 candies left. So we can put 48 candies on this number line to show that she had 48 candies left. But we know that she gave the same number of candy to each of her 3 brothers, so we'll divide. So after we do 72 minus 48, we get 24, and then we get 24 divided by 3, which equals 8. And that's how we have 8 candies for each brother.
Okay, so now we're going to do another problem similar, and we'll see if Megan here, our student, that kind of takes on the problem in the same way. So it says James has 122 new songs on his iPhone. After listening to the same number of songs each day for a week, he had 66 songs that he had not heard. How many songs did he listen to each day? So we'll give her a little bit of time to work that out as well.
Five? Yeah, 5. 7? Right? Yeah, because it's a week. Was that 6? Is that right?
Yep,
Okay.
doing good.
Okay, I think I'm done. Is it 6?
Wait, how many times does 7 go into
I don't
56?
even know. I don't know. 8.
There you go. Good job.
Got it.
Awesome.
Okay, so we'll look at it and see how she did.
Oh,
Maybe.
technical difficulty. There we go.
Okay, so it's set up similarly to the last problem. We set up on this number line, there's 122 songs total, so that shows the whole total as one solid whole. And then we split it into 7 little sections here to represent a week. Since there's 7 days in a week, that's why there's 7 boxes. The 66 represents how many songs that he already had heard, so then you would subtract it. So it would be 122 minus 66, which is what Megan here did. So then you get 56. And then since there's 7 days in a week, you would divide it out. So 56 divided by 7 is 8. So the answer is 8.
Alrighty. Okay, so then now we'll just go into the definition of MP7. So the definition is really to discern pattern of structure. And to discern, we looked up the structure definition from dictionary.com just so that we can give a more concise definition, which is a mode of building, construction, organization, arrangements of parts, elements, in which all represent a pyramidal structure. Then we found this really cool quote that would break down structure and how we could relate it to a classroom. It relates to an analogy of a castle. So studying math is like building a castle in your head. When building a castle, you first must learn to build a brick. And once that is mastered, you can see how it is used to build a wall. Once you can build a wall, you can build a tower. Stronger bricks allow for higher walls and bigger towers. Additionally, powerful tools allow you to build faster and more efficiently. And then we kind of just added on, this is really small, so sorry, about an example that we did from the Common Core Standards of Math. And that's that students will see 7 times 8 equals the well-remembered 7 times 5 plus 7 times 3. In preparation for learning about the distributive property, which is kind of how we used our last exercise for the M&M activity that we did for our first presentation. And then as it gets more advanced, there's an expression of x squared plus 9x plus 14. Older students can see the 14 as 2 times 7 and the 9 as 2 plus 7.
Okay, so now we're going to try a problem that is for a higher level, more of high school level. So here's a problem here. It's 46y plus 12y times 2 equals 8. So if we go through this, we'll break it down first. So this is kind of breaking it down into chunks. So I wrote down the problem here. I don't know if you see it. Okay. So basically you're needing to see what numbers go together. So these two with the y's are like terms. So the 2 is not, so you kind of need to get rid of the 2. But first we will add the like terms. So 46 plus 12 is 58. And then you tag on the y. And then you'll add the 2 in there, so times 2 equals 8. So then after this, according to the order of operations, you're going to divide the 2 on each side. So you can cancel those 2 because it's not there anymore. Divide by 2. So then if you rewrite it, it's 58y equals, and then 8 divided by 2 is 4. So then you want to get y by itself. So what you're going to do is you're going to divide, so you're going to do the opposite. So 58y is multiplication, but you need to divide to get rid of it. So you're going to divide by 58, and then cancel that out, and then divide this side by 58. So whatever you do on one side, you do that to the other as well. So then you get a fraction, but the fraction can be reduced. Since they're both divisible by 2, you can divide each by 2. So 4 divided by 2 is 2, and 58 divided by 2 is 29. So then that would be your answer. And that just follows each little step individually.
All right, very nice. Okay, so we still kept our adaptations for K through 6. So that's really talking about the problem out and making it into chunks for the students to see one thing at a time. That's kind of how we broke up each of our problems, by breaking out the word problem so that students will understand it better. Giving students extra time to work, so how we let Megan work and let her work at her own pace. And then let students know that struggling is okay, so we helped Megan out with part of the problems. And then giving students brain breaks. And as you can see, Megan was a pro, so she kept going, but students might have difficulties with these exercises, so it's important to make sure that we give them a break and let them know they can always come back to it. Okay, how we integrated SciUp again. We integrate processes of reading, writing, and listening. So as you can see, we kind of spoke the problem out and let the student read along with us. And then we had the students write the word problem out so that they can make structure and use out of the MP7. And we also had the students listen to us as we verbally said it. And then students need to know operations like addition, subtraction, multiplication, and division in order to apply different equations within the same problem. So Megan really broke that about by using the order of operations, and students need to use prior knowledge of addition, subtraction, or multiplication, division to have a better understanding of the problem. And then students will need to grasp basic vocabulary skills, so that's kind of how Megan did that with the addition, multiplication, and to recognize what students need. And then we'll go back to Megan.
Okay, so then the rest of it here, it says have students use a self-questioning strategy. So for example, they can question for the word problem, for example, how can I set this up to make a problem or an equation to solve the problem? So that's kind of how we incorporated it into the word problems, whereas last time was a little bit different with the M&Ms. Also, the teacher can discuss what they've learned previously as of terms, and with that, that's why we did 2 different problems, but they were similar in structure, just because the first one we kind of had the students struggle a little bit, think about it, and then the second problem, once they recognized it, they were able to think of it differently. So that could be another way, and that is kind of creating the prior knowledge at the same time. And that also creates the aha moment on the second try. Students can also participate in a warm-up activity, and that kind of relates to the same thing. Like, we warmed up by trying an activity, even if they haven't learned it before, and then reincorporated it another time with a different problem. And then I know last time we talked about the you, y'all, we. Basically, the you just means that the students will try it, kind of like Megan did, and then y'all, which will try it as a class, and then we go over it as a class together. And then
those are references.
The end.
Thank you so much.